All right. Yeah. So we had a great conversation in the geology and geophysics breakout. I'll post the link to this when I'm done talking, when I see the chat again. But we came up with, I think about, yeah, eight or nine sort of distinct activities. Some of these are grouped together, and that's why there's multiple numbers. The first activity is basically sort of field investigation, sort of geologic mapping, those sorts of things. So field scale mapping activities. So we're talking about field scale. We're talking about, maybe a couple kilometers, sort of a walking traverse, maybe further if it's enabled by something like a mobility asset, like a rover. Um, so things that we might be interested in mapping in more specific detail, more systematically, are impact cratering processes, and finding shock metamorphosed rocks and those sorts of things. Maybe mapping faults on lunar surface. So the kinds of activities that we wouldn't have time for at a sortie kind of mission, that having a long-term base camp, and also more people to contribute to these activities could enable. Mapping fresh impact craters, or other fresh young surface processes like mass wasting, those sort of things. Investigation of field scale compositional anomalies. So great example is the orange soil on Apollo 17. So if we had a field-based tool deployed by astronaut or robots, or in concert with one another to detect and characterize those kind of anomalies, again, in the context of sort of more systematic field-based sort of mapping. The second category was deployment of instrumentation. Heat flow is one example, but there are others: seismic, magnetic instrumentation in geophysically quiet areas like a PSR, and also to do PSR science with those kinds of instruments. So following along with that, there's sort of a couple of different activities related to the deployment of sensors, using humans and then tending to those sensors. So at a small scale, sort of doing sort of small scale environmental kind of geophysical sort of transects, with things like seismic, GPR, resistivity, to understand sort of the near surface, and also perhaps the human sort of impact on the geological environment on the moon. There's some overlap with the things that you talked about in your group, Ben. Um, Also, at larger scale, sort of deployment of kilometer scale sensor networks, and setting up those sensor networks on the lunar surface. Another category that we talked about was sort of more applied geology and geophysical kind of field activities related to ground truthing, orbital observations, other observations in support of things like ISRU. The sixth category was basically the kinds of sample kind of science that we might be able to do at base camp or around base camp. So that includes essentially doing limited sample curation, preliminary analysis, processing, maybe some short-term storage of samples, high grading samples. I know that's a little bit of a tricky thing to think about. And also limited sample analyses at base camp, if not in the field, with things like handheld instruments. Number seven here, and this sort of ties back to some of the network stuff I talked about earlier, but some of the geophysical kind of networks that could be set up around base camp would be specific to monitoring hazards. So there are a number of geologic, geophysical hazards like impacts, including monitoring, maybe like meteor showers, earthquakes, mass wasting events. The sensors and the deployment strategies for those kinds of geophysical monitoring might be different than for geophysical science, that's less applied. So that's why it's a different category. And then at the end there, I have two things that I added that we didn't really talk about at too much length, but one of these is volatile science, and there might be some overlap with what some of the other breakouts might have considered for that. And the last one that I added was there's the capability, or at least the opportunity, afforded by long-term presence at a place like Artemis Base Camp, to maybe get to hard to get to environments to do science. What I mean by that is, places that are, if not difficult, then at least sort of time-consuming to get to, things like the crater interiors, PSRs, the lunar subsurface, if there's caves or whatnot, to really investigate those Overall, sort of what I was seeing sort of as a common thread is that the Artemis Base Camp can afford things like um, longer time to do science on the surface of the moon. There's less time pressure than you would see on sort of a sortie mission. Um, there's also less return mass pressure, right? Especially if we can do things like preliminary analysis, curation there on the lunar surface, if not analyses. There might be more personnel, right? We're not going to have just two people at the Artemis Base Camp. Hopefully, we'll have more expertise to bring to bear, including potentially folks that might be sort of trained differently than current astronauts are. So those are the kinds of sort of overview kind of infrastructure sort of things that are enabling. On the second sheet, we talked about some of the specific sort of infrastructure for some of the mapping activities, things like suit or human sort of carried instrumentation, including things like cameras, spectrometers, IT infrastructure to enable documentation of field observations. What I think is very critical is geolocation and communication infrastructure, navigation, all those sorts of things are going to be very important, I think, for these field and also instrument sort of related activities. For instruments, we need sort of mobility in order to deploy them sort of over long distances, as we might think is valuable. The ability to enter, survive in PSRs, if not with humans, then essentially definitely with robots. Um, let's see, for some of the geotechnical and also sort of geophysical activities we talked about, instrumentation sort of overall, but specifically things that would allow us to get to greater depths into the subsurface. So for drilling, for instance, for the activities related to sample science at base camp, we need to think about sort of how to do that. We need sort of facilities that aren't co-located with living quarters, for instance, and the appropriate kind of instrumentation. We don't necessarily need sort of super high-tech sort of full-featured labs. That might not be viable, but definitely things like microscopes, XRF, libs, photography, IT support to support large data volumes, those sorts of things. I think that sort of high level sort of covers what we discussed. We started putting names on some of these potential white papers, and I will stop sharing my slides.